Hey, welcome back. Today we are going to solve another programming puzzle from Kattis, and this time it's going to be the Stirling's approximation. So as you know, the value for the factorial of n can be really large, and computing it would be pretty much CPU intensive, but there is a pretty good approximation for that, and it goes as follows. So instead of computing the factorial of n, we can compute s of n with this formula, which is also known as the Stirling's approximation. Now what we want to do in this puzzle is that we want to know how good it actually is, and to do that we need to compute the ratio between the actual value of the factorial of n divided by the approximation for different values of n. And we would expect it to be very close to 1 because we say that it's a very good approximation. Let's have a quick look at some examples. So if n is 1, the factorial of n would also be 1, and the approximation will be 0.921, which is very close to the actual value of the factorial, and therefore the ratio would also be very close to 1. The same thing applies to the other numbers like 2, 5 and also 10. So you can also see that as the number gets larger, the value for n, our ratio also gets closer and closer to 1. For this puzzle, we want to compute this ratio. Let's do just that, and we begin by computing the numerator. As you know, the factorial of a given number is equal to all of the integers or all of the positive integers that are less than or equal to it. However, computing this would be very computationally expensive, but a workaround would be to compute the logarithm of the factorial of n, which turns all of these multiplications into addition, and it's going to be way easier to compute. Great, now let's deal with the denominator. So this is going to be the Stirling's approximation, and as you can see, it's the product of two terms, this square root and the fraction. Now if we take the log of the s of n, it's basically transforms this multiplication into addition, and now because both of the values n and e here have the power of n, we can bring the power behind the log based on the laws of logarithm. And now the same thing applies here, because the square root of x is equal to x to the power of half. Therefore we can also bring this power behind the log, and at the end we would end up with basically with this expression. Great, let's just quickly summarize. We wanted to compute this ratio. Because it was computationally expensive, we decided to take the logarithm of the ratio, and because of the laws of the logarithm, this would turn into basically this expression, because we take the logarithm of the numerator minus the logarithm of the denominator. Let's say that this is equal to x. Now, because we want the actual value of the ratio, in order to be able to compute that, we need to use this as the power of e, because e is basically the exact opposite of logarithm. Like the same way that division is the opposite of multiplication, we can use that to get to the actual value of the ratio. Now let's code it in Python. Now that we know what we want to do, implementing it in Python would be very easy. I have already imported the modules that we need from the math library. We now just need to first write two functions that would compute basically the logarithms of the factorial and also the approximation. Let's begin by that. Let's first write a function to compute the logarithm of the approximation, Stirling's approximation. So I'm just going to basically just implement the formula. Great. Now we also need a function for the factorial, for the logarithm of the factorial. Now we need to just basically return the sum of all of the logarithms starting that are less than or equal to the number. So that's going to be easy. great. Now we just need to receive the input and print the output. As you know, the output would be the ratio between the two, and the input will be different test cases on different lines, and the input would end when n is equal to 0. So to do that, let's use a while loop. So we are going to just receive n and convert it to an int. Then the exit condition would be when n is equal to 0. In that case, we just break the loop. Otherwise, so we said that we need to take e to the power of the difference between these factorials. Great, let's also test it. So the first value would be 1, that's correct. Then 10 is also correct. 150, again we have the correct result, and with 0 we just exit the loop. Now that shows that we have solved the puzzle correctly. And with that, this tutorial also comes to an end. I will post the codes on my website and share the link to that in the captions of this video. Thanks a lot for watching, and see you in my next tutorial.